Today's calculus 3 is brought to you for a live video. Here's a problem that I want you to work on. I'm giving you two functions. Z is a function of y, and z is also a function of x. And I've given you some sparse information about the functions, and I want you to answer these three questions. Two calculus, one kind of a bonus question. First, I want you to approximate g prime of 6 and h prime of 6. Then I want you to find overestimates and underestimates for the definite integral from 0 to 6 of g of y dy, and the definite integral from 0 to 9 of h of x dx. I want you to show your calculations and draw a picture of where those calculations came from. Then, if you got some spare time and you like a challenge, I want you to find formulas for g of y and h of x. One is very simple. One of them requires that we look a little bit closer. So pause the video and you can work on these problems. All right, welcome back. So note that we don't have all the information that we really need to find g prime of 6 and h prime of 6 exactly. We have kind of sparse information about it. So let's just start with the simplest thing that we can do. What we're trying to do is find out what direction this g of y is headed when we get to 6. All we have is what's been going on over the last 2 units. So we really can't do this limit as h goes to 0 because we're kind of stopped. The difference is going to be 2. That's as good as we can get. We know that g prime of 6 is going to be the slope of the tangent line. We don't have enough information to get a tangent line, so we're just going to have to approximate. We're going to do the best we can. So for problem 1, we're approximating tangent lines. So g prime of 6 will be approximately the change in z divided by the change in y. Z went from 6 down to 2, so I'll just write it out. And y went from 4 to 6. That's the best we can do for g prime of 6 with the information that we have. Any questions? That's what derivatives are asking about. What's the slope of the tangent line? We don't have tangent line information. Best we can do is this approximation with this secant line. Then we'll do the same thing for h prime of 6. Now in h prime of 6, I just remembered why I use 6 and not 9. For h prime of 6, we have 2 different sides we can go on. We can go what's happening before 6 and what's happening after 6. So 2 choices for h prime of 6. So I could do a before approximation. What was happening before 6? I still just want to do change in z divided by change in x. We're just finding rise over run. The change in z, I'm going to go from 3 to 6. I'm going to think of this one as the before. Z went from 16 to 20. And x went from 3 to 6. So 20 minus 16 is 4, 6 minus 3 is 3. That's what I'm referring to as before. That was a slope using the information before 6. That's not official terminology. That's just local terminology that we're using so we can picture. But we could also look at what's going after 6. So go from 6 to 9. So h prime of 6, we could also reasonably say still delta z over delta x. Z went from 20 to 26. And when x went from 6 to 9. So presumably, we can say that h prime of 6 is somewhere between 4/3 and 2. Question? It's not going to be the same, but that would be that's a reasonable thing to do. Good choice. I didn't think of that one. Like, well, what's happening from 3 to 9, because that covers the 6. And we wouldn't have the issue of having 2 pieces of information, 4/3 and 2. Now, the natural thing to do here would be to find the average of these 2 numbers. You need to resist just finding the average. Averages are terrible. We use averages for so many things, even though they're utterly awful. For example, the average human being has 1 ovary and 1 testicle. But that's terrible. That doesn't work. I realize that that example is not similar to what we're doing here, dealing with a continuous or a supposedly continuous function. So don't at me. But I just want you to get over the urge to just average stuff. But we do get some more information. Going into 6, we are at a slope of 4/3. Coming out of 6, we're at a slope of 2. So we do know some more information. This tells us that h of x is concave which way? H of x has concavity because before 6, we were at 4/3, 1 1/3, and after 6, we're at 2, 1 3/3. So we can note we have pretty strong evidence that h of x is concave up because h prime seems to be increasing. So, unfortunately, we're out of time because I was talking too much. So, tomorrow, we'll take a look at what we want our definite integrals to look like and what we want the sketches to look like. Because we're going to take this problem and we're going to build on this problem. We're going to look at these 1 variable problems, and then we'll come back tomorrow and try to build it into a 2 variable problem. But for now, that's it for today. I'll see y'all on tomorrow. Everybody have a good day, and thanks for playing.